Hi, welcome you all. So this session we are going to see about algorithmic problem solving and simple strategies for developing an algorithm. So algorithmic problem solving is a method to solve the problem that required the formulation of an algorithm for the solution. If any problem occurs, we need to give a formulation for that problem to occur a solution. So this diagrammatic representation shows the flow of solutions where we can get a solution for the problem. So first step, we need to understand the problem properly. So what problem they are raising, we need to understand it properly. And next is deciding how the computational and exact approximate solution and what are the designs of technique we need to use for that particular problem we need to identify next. So third one is designing an algorithm. How to designing an algorithm, in what aspects we need to design it, and prove the correctness. So how to whether the given algorithm is a perfect solution for that problem, we need to identify that and we need to correct that and analyze the algorithm. Finally, code the algorithm. So analysis we need to do in proper manner, and if it is get success, we need to go for the code for that algorithm. So this is the step-by-step process where we are going to do the algorithmic problem solving. So next one is understanding the problem. So we will see one by one so that we can understand what is this all about. So it is the process of finding the input of the problem and then the algorithmic solves. It is very important to specify exact set of input and algorithm needs to handle. A correct algorithm is not one of the work most of the time, but one of the work correctly for legitimate inputs. So that means that whatever solution we are giving for that algorithm, we won't consider it a perfect solution. It may be a ambiguity wise of solution it may be. So we cannot say it as a perfect algorithmic solution. So to avoid such scenario, we need to understand the problem is very important, and we need to continue in the same aspect. So next one, we need to select the technique. So an algorithm design technique or a strategy or a paradigm is a general approach to solve problem algorithmically that is applicable to a variety of problems from different areas of computing. Learning these techniques is of utmost importance of the following reasons. First, they provide guidance to the design. Second, algorithms are a cornerstone of a computer science. So analyzing an algorithm. So if we can analyze this algorithm in two aspects. One is efficiency and one is simplicity. So efficiency, there are two parameters are available. So one is time efficiency, another one is space efficiency. So in time efficiency, it indicates how fast the algorithm runs, and space efficiency includes how much extra memory it is utilized. So next one is simplicity. An algorithm should precise, define, and investigate with mathematical expressions. Simpler algorithm are easier to understand and easier to program. Simple algorithm usually contains fewer bugs. So next one is simple strategy for developing an algorithm. There are two commonly strategies are available to developing an algorithm. So one is iteration fashion, another one is regression. So iteration is nothing but the iteration is when a loop repeatedly execute till the controlling condition becomes false. The iterations is applied to the set of instruction which we want to get repeatedly executed. The very important example for this iteration is concepts for example concept for this iteration is loops. Loop, there are two types of loops are available. We are known well known about these things, for loop and while loop. The iteration includes three major things. One is initialization, which is helps to where the loop starts, and the condition, which helps to where the loops gets to be end, and the execution statement within the loop which update increment and decrement and control variables. So we'll see one by one. So first one is for loop. So this is the syntax of for loop, where the statement is inside it and where the for loop is gets end, it's also declared here properly. So this is a sample pseudo code which is given for a print n natural number. So it's begin here. We need to get a n first of all and initialize an I. I is a looping variable. With that I, we up to the n, we need to do the print. Natural number means whatever numbers n we are giving till that from 0 it will be, sorry, from 1 it will be displayed, and the I gets incremented so that the loop until the n is met, the loop will be performed, so the output will be displayed properly as a natural number. So whereas in while loop, same thing is going to be followed, but here the condition already it will check the conditions, the statements will be here, but whereas like for loop here initialization, we need to give here I is equal to 1, and one same like for loop here also while loop will be there, so it will check the condition up to n, and here the increment counter will be employed. Based on the counter, the loop will be performed, and both the program, both the concepts, same results will be displayed. So this is the diagrammatic representation of that strategies. So it starts here, and the input n will be get here by parallelogram symbol, and the process I is equal to 1 will be then the condition will be checked through the symbol. If the condition is yes, the I is going to be print, and the I is get incremented, and again the process is doing once again repeatedly. If the condition is met false, then the loop will be terminated and it goes to the end of the program. So this is about the example way of simple strategy, one of the strategy, simple strategy to develop an algorithm. The next one is a regression. So regression itself a function that calls itself again and again is known as regression. Regression is a process by which a function calls itself repeatedly until some specific condition has been satisfied. So this is the algorithm for sample algorithm for factorial of n numbers with using regression. So the first step it gets started. Next one you will get the n number. Next the function is getting called. Then inside the function, some things after getting the output of the called function, it will print the factorial. Then the program is stopped. So for that, when the calling function with the called function, calling function we need to define. So here is the calling function. Step 1, if n is equal to 1, then the fact is equal to 1. It is because factorial 1 implies the output 1. If not, the factorial is going to be called once again insidely. So it is a recursion. Here the factorial of n minus 1. So automatically then n will be get decremented, and once again it calls the function. So it is called and it get multiplied with n. So as a result, final output of fact will be the factorial. So this is the perfect example. So with this, we can clearly understood about the scenario. So here is the flowchart for the both scenarios. Here it starts and get the input is get through the input. So here the calling function is calls. It is a allied function. So when it is called, automatically the cursor is gone here. The factorial of n will be deployed. So and the condition is checked. If the condition is checked, the factorial is 1. If not, the factorial is get recursive. Until the condition is met, the process will be repeatedly doing. Final output will be written from this function, and it will comes here. So the print function will print the output of factorial, and it's stop. So with these scenarios, we can clearly understood about the second strategies of algorithm, that is recursion. Thank you.